We're going to tackle some trickier chain rule problems, so using more product and quotient rules embedded with the chain rule. So let's go ahead and get started on the first problem. We're going to rewrite this. Sine of 4t raised to the fourth power. What is our outside function? That is our function raised to the fourth. Our inside would be sine of 4t, and then the innermost part is 4t. So we start from the outside. Y prime is equal to, we bring the 4 to the front and leave everything on the inside. So sine of 4t. The power of 4 gets reduced to a 3. Then I multiply by the inside, which is sine of 4t. So the derivative of the inside, which is the cosine of 4t. Wow. Okay. The cosine of 4t. And then the innermost, the purple part, is times 4. So we go ahead and simplify. 16 sine of 4t cubed times the cosine of 4t. Okay, the next one is, it looks funny. So what is our outside function? Our outside function is to the fourth power. And then the inside function is sine. It's basically sine. Oh, this is the one that I wrote down wrong, so I'm going to rewrite it. Sine of 2x plus 4x squared, all raised to the fourth power. Okay, start again. The outside function is to the fourth power. The inside function is the sine is all of this. These are two different functions here. Okay, so the next level is to take the derivative of sine of 2x and the derivative of 4x squared. Now, the inside of sine of 2x would be 2x. All right, so here we go. Y prime is equal to, we're going to bring the 4 to the front. Man, we're just loving these to the fourth powers, I guess. Times everything on the inside, which is the sine of 2x plus 4x squared. And then I reduce my power to a 3. Okay, now I'm going to take the derivative of the two purple pieces. So the derivative of sine 2x would be cosine of 2x, but don't forget to take the derivative of the inside times 2. All right, now we're going to take the derivative of 4x squared. So I get the derivative of 4x squared is 8x. All right, now we just go ahead and simplify, giving us y prime is equal to, I'm just going to rewrite this, 4 times the sine of 2x plus 4x squared raised to the third power times 2 cosine 2x plus 8. So I guess I can rewrite that as y prime is equal to, since we took the derivative of the inside, I can see that this parentheses, everything in the purple layer is together because because that's one derivative from the inside. Okay, so it has to stay together. We're taking the derivative of the inside, which is this. All right, so I can stop there. All right, next up, find the derivative of the function. What's the outside? What's the inside? What kind of rules are we going to use? All right, I have a lot of rules going on here because I have two factors, or I have factors. So I have the factor of 2x minus 1 squared and cosecant 2x. So that together these are going to give me the product rule. And then within the product rule, I can see that I have chain rule happening. Outside, inside. outside, inside. So first the product rule is left d right, right d left. So left d right plus right times d left. Okay, so I'm going to go ahead and start with that. So f prime of x is equal to in the blue, I'm going to take the left factors, which is 2x minus 1 squared, and then take the derivative of the right. So the derivative of cosecant 2x using chain rule would be negative cosecant of 2x times the cotangent of 2x times the derivative of the inside, which is 2. So the derivative of the inside. And we need another set of parentheses. Then we have our right, which is the cosecant of 2x times the derivative of the left, the blue. So the derivative of the blue is using chain rule, bring the 2 in front, keep the inside, 2x minus 1, and reduce the power by 1. So to the first power. Then we have to take the derivative of the inside. So the derivative of 2x minus 1 is times 2. All right, let's just simplify a little bit. I get, this is a mess, negative 2, so I'm going to take the negative and the 2 to the front, times 2x minus 1 squared times the cosecant of 2x times the cotangent of 2x, plus I'm going to take the 2 and the 2 to the front, so plus 4 times 2x minus 1 to the first power times the cosecant of 2x. All right, and that's it. Combining rules. Okay, so we're going to find the equation of the tangent line of the graph of 2 times sine x plus cosecant 2x, cosine 2x, at the point pi comma 1. And what we're going to do is then determine all of the x values in the interval 0 to 2 pi. And then we're going to graph where the tangent is going to be 0. And I'm going to write some stuff down. We're going to If we want to find the equation of a tangent line, then we're going to write the equation in slope point form. And we already know the point that the graph goes through. It goes through the point pi and 1. So we just need to find the slope when x is equal to pi. So we're going to go ahead and take the derivative, which is 2 times cosine x plus, chain rule here, negative sine of 2x times the derivative of the inside, which is 2. So just rewriting that really quick, f prime of x is equal to 2 cosine x minus 2 sine of 2x. Okay, so that's our derivative. I want to find the slope when x is equal to pi. So I'm just going to substitute in pi for x, and that'll give us the slope. 2 times the cosine of pi minus 2 times the sine of 2 pi. And just a reminder, when I have 2 pi and pi, the coordinate is 1, 0 and negative 1, 0. So I have f prime of pi is equal to 2. Cosine of pi would be negative 1 because it's the x coordinate. The sine of 2 pi is 2 times my y coordinate, which is 0. So f prime of pi would give me a solid -2. This is also the slope at x equals pi. So we can write our equation now. Y minus y1 was 1 equals -2 times x minus pi. This is our tangent line at x is equal to pi. And we can tell that we have to say where the tangent line is, because at every x value there's a different tangent line. All right, the horizontal, let's go here. The horizontal tangents is when f prime of x is equal to 0. So I'm just going to go ahead and substitute in 0 into my tangent function, which is, sorry, my derivative. 2 times the cosine of -2 sine of 2x. And we're going to have to do some algebra. Okay, so I'm going to divide both sides by 2 because that seems fair and easy. So I get the cosine of x minus the sine of 2x. And I remember from trig that the sine of 2x is equal to 2 sine x times the cosine of x. I see good things happening already. Since I have a 0 on the left-hand side, I can use zero product property, but I need factors. So I can factor out a cosine of x, and I am left with cosine divided by cosine is 1 minus 2 sine of x. Now I can use zero product property. So I get the cosine of x is equal to 0, and 1 minus 2 sine x is equal to 0. So cosine inverse of 0 is equal to x, and sine inverse of 1/2 is equal to 0. So we're looking for when is the sine value or the vertical value equal to 1/2, and when is the horizontal value equal to 0. So what I'm going to do is, I remember that the cosine of inverse of 0 is pi over 2 and negative pi over 2. So this is x is equal to pi over 2 plus pi n, because the values are 180 degrees away from each other. So in the interval 0 to 2 pi, I only have answers that are pi over 2 and 3 pi over 2. For the second part, sine inverse of 1/2 is equal to 2x. That should be an x. Sorry. So x is equal to, this is pi over 6. So pi over 6 plus 2 pi n, or x is equal to 5 pi over 6. Okay, when I add 2 pi, that gets me outside of my domain. So I'm going to have x is equal to pi over 6 and 5 pi over 6. And that's it. All right. The next type of derivative is absolute value derivatives. We can derive these, but the trick is that if you're taking the absolute value of a function, there is a little chain rule action going on underneath here. So what we're going to do is take the function itself, divide it by its absolute value function, then multiply by the derivative of that function. Okay, so here's an example. We're going to make the inside part of x squared minus 4. That's going to equal u. So we take the inside part, so dy dx would equal u is x squared minus 4 all over the absolute value of x squared minus 4 times the derivative of the inside, which the derivative of x squared minus 4 is 2x. And we're done with that one. Okay, so let's get a little trickier. So the derivative of the absolute value of 2x times the sine of 5x. So I have product rule happening. So 2 pieces being multiplied together. So this is product rule. And within the product rule, I have chain rule and absolute value rule, which is a form of chain rule. Okay, so we're going to start. dy dx is equal to, or yeah, that's fine. We can say dx of the absolute value of 2x times the sine of 5x is equal to, okay, left d right. So the absolute value of 2x and then the derivative of sine 5x. So the derivative of sine 5x would be the outside is cosine of 5x times the derivative of the inside times 5. Next, we add on so we had left, d right, now we need right. So sine of 5x times the derivative of the absolute value of 2x. So again, u is going to be 2x, so we get 2x over the absolute value of 2x times the derivative of 2x, which is 2. Simplify this to give us 5 times the absolute value of 2x times the cosine of 5x plus 4x. Yeah, combine these to give us 4x over the absolute value of 2x times the sine of 5x. Okay, so the last part is these are your basic differentiation rules. You need to know them. So it's just all about practicing and getting familiar. You can do your WebAssign problems, or likely you're going to have to do some extra practice. So also do some of the problems from your book. So if you know, like, I need more practice with chain rule, go to chain rule and make sure that you do some of those problems that I listed. If you have questions, you let me know.